All right, here we're starting our new chapter and looking at section 11.1. So for this section, we're going to be using the formula for circumference. Then we're going to be using arc lengths to find certain measures. Then we're going to be looking at solving some real-life problems. And then we're going to be measuring angles in radians. Right? We've been measuring angles in degrees, and so now here's just a different way that we can measure those angles. So the first thing we need to revisit is the circumference of a circle, and hopefully you've seen this before. So I know the circumference of the circle is the entire length around, right? It's the kind of the fence around my circle. So the circumference equals pi times the diameter, or 2 pi times the radius, right? Because the radius, if you multiply that by 2, I get the diameter. So either one of these formulas will work for the circumference of my circle. So here's our first example. First, we need to find each indicated measure. So find the circumference of a circle with a radius of 9 centimeters. Okay, so I go ahead and use my circumference equals 2 pi r, and then I plug in what I know. Well, I'm trying to find the circumference, but I know the radius, so I can plug that in, and I get 18 pi, which is approximately 56.55. Sometimes you're going to be leaving this in terms of pi, so you can leave it in terms of 18 times pi, and that's just fine. So now here for part B, we're looking to find the radius of a circle with a circumference of 26 meters. So I use my same formula, my circumference equals 2 pi r, and I plug in my circumference because that's what I know. So now I divide both sides by that 2 pi in order for me to find that r, and I can use my calculator and find that the radius is about 4.14 meters long. So here are the first few I want you to try by yourself and see how you can do. So now we're looking at arc length, right? So we looked at the circumference was the entire direction around the circle. Now we're looking at arc length. So the arc length is a piece of the circle, a piece of your circumference. So here's how I kind of remember it. I take my little piece, so the arc length, right? Because the arc length is the smaller piece, divided by the entire circumference, right? So you see this 2 pi r, that's the circumference of my circle, equals the measure of that arc, right, in degrees over 360. And 360 is my whole circle. So what I see is I have the little piece over the big whole thing equals the little piece over the big whole thing, right? And that's how we can always set up our ratio is as long as we keep those the same, we'll be just fine. So now let's try this. So I see I have an arc, I'm trying to find the arc length of AB. So this red piece right here. So I know I'm going to find this over the whole thing equals this measurement, this angle, over 360. So I plug in the information that I know. So the arc length over the entire circumference, which is this 2 pi times 8, right? Because I was told my radius was 8. Equals 60 over 360. Then I multiply both sides by that circumference, and I find that this arc length is approximately 8.38 centimeters. So now I'm trying to find the entire circumference. So I'm given the internal angle, and I'm given the arc measurement. So now let's figure this out. So I've got the arc length over the circumference equals the measure of that angle over 360. So now let's plug in what I know. I know my arc length is 4.19. My central angle was 40 degrees. So I plug in the things that I know. Now I can just multiply, cross multiply, and solve for C. So I know that C is about 37.71 inches. So now let's look at this third one. So here I'm trying to find the measure of arc RS. Okay, so I'm given the radius and I'm given a piece of this. So now let's see what we can find. So I know the arc length, and I know the radius, so I'm trying to find my central angle, right? So I've got my same setup. My little piece over the circumference equals the little angle over the whole circle. So now I can just plug in what I know and what I'm given, and then simplify by multiplying both sides by 360 and solving for that. So I see that that angle is about 165 degrees, which if I look at the circle, that makes a lot of sense, seeing as this is a pretty big angle. It's not quite half of my circle, but it looks like it's close. So mathematically, I think I'm right on. So here are a few that I want you to try using those same steps that we just did. So here's our real world problem. Okay, so the dimensions of a car tire are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? So we first have to think of what I'm looking for and what information I need to have. So I know I'm going to need to be dealing with the circumference. because that's going to be my distance that the tire travels. So first I have to find the diameter, which is the entire length across, which I see is this 15 plus this 5.5 plus this 5.5. So my diameter was 26 inches. So now I have to find the circumference of that tire, which I can just use because I know the circumference equals pi times that diameter, which gives me 26 pi. So now I know that I'm dealing with 15 revolutions. Okay, so in one revolution, my tire travels a distance equal to that circumference. So I'm going to have to multiply my circumference times 15 to give me the total distance traveled, which is approximately 1,225.2 inches. So then I can change it to feet, because I was asked in my question to the nearest foot, how far does it travel? So I always have to keep in mind, what am I actually looking for? So I know that I have inches so far, and I'm trying to change it to feet. So I know that there's 12 inches in 1 foot, so I can set up that ratio and multiply and divide. So I end up with 102.1 feet, so approximately 102 feet. So here's our next problem. So the curves at the end of the track shown are 180-degree arcs of circles. The radius of the arc for a runner on the red path shown, right, so we've got the red path and the blue path, is 36.8 meters. About how far does this runner travel to go around once around the track? Round to the nearest tenth of a meter. So here I see I'm given the length of the straight edges of this, and I'm told I have to find this distance. Well, one thing I know is that there's 2 of these, and it said that each end was 180 degrees. So I know that if I have both of them, that's an entire circle. So I'm given the radius of my circle, and I have to find the entire distance. So let's figure out what we've got. So I know I have to do 2 of the straight sections, right? So this one and this one, which gives me, which I can just plug in as 84.39. And then I know I have to do 2 of these half circles, right? So or in one entire circle, and I'm given the radius here. So now I can just plug it in and see that it's about 400 meters. So here are some for you to try, just to see how you can do with these. So now we're going to be looking at this final learning target going from degrees to radians. One thing we need to keep in mind is we've looked at circles a lot, and we know that one circle is 360 degrees. We also need to just know that one circle is 2 pi radians. Okay, and I always think of degrees and radians kind of like when we measure temperature. We can measure temperature in both Fahrenheit and Celsius. It measures the same thing but using different units. Here we're doing the same thing. We're measuring the same thing just using different units. We're using degrees and radians. So what I know is if I'm going from degrees to radians, my radians is going to be on the top, right? So since that's what I'm looking for, that's going to be the piece on the top. If I'm trying to find degrees, the degrees is going to be on the top of my ratio, okay? And as long as I remember that 360 equals 2 pi radians, we'll be just fine. So now let's look at these. So I'm converting 45 degrees to radians. So I know I'm going to radians, so my radians is going to be on the top. So I can take that 45 and multiply it by either my 2 pi over 360 or 1 pi over 180. Okay, so now I can just simplify. I want to leave pi alone. Don't actually use your calculator, so just simplify your fraction so I end up with pi over 4. So now we're converting from radians to degrees, so I know that my degrees is going to be on the top. So now I can simplify. We'll now see here I have a pi in the numerator and a pi in the denominator, so that can cancel out. And then I can just multiply my fraction straight across, so 3 pi over 2 is the same as 270 degrees. So now here are the ones for you to try with converting back and forth between degrees and radians. So let's look back at our learning targets. First, we use the formula for circumference, and we use this formula using both the radius and the diameter. Then we use different arc lengths to find certain measures. Then we looked at some real-life problems, and then we were going back and forth between degrees and radians in our angles. Now we'll go ahead and work on your homework.